Hello everyone, this is Bradley. Today we are going to talk about this pottery wheel animation I was saying being done in Houdini. I think this can be done in Blender, so let's start. So here we're in Blender. As always, I'm going to use the presets which you can download for free from the link in the description. My throat still didn't really recover, so I try to be as simple as possible. And as a noding, which means I haven't done this animation before, it carries a huge risk of failure, which will again waste my throat. But anyway, let's start with a China pot. So we have curved linear, which is just a curved line, and I make that shooting to the sky without the centering, and we're going to bevel curve. I made tutorials talking about tornado, the stylized tornado. So basically we're doing the same. Make that to 64. And maybe we want to fill the caps at the bottom. We may just use a curved circle. Actually, people won't really see that. Let's forget about that. Okay, so this is the China pot we have. This looks like a cylinder, but it's open on the top. Okay. And if you are going to make a static one, then it will be very easy to just set a curve radius and use a spline parameter. And we take a float curve. We can reverse it. And you just draw, because the spline parameter starts from 0 to 1, and I don't actually know how to draw it, and also you need to be aware of the count you have. So I hope it looks like something like this. It's difficult to draw. Anyway, so something like this. Oh God. I'm really bad at drawing this thing, but I guess something like this, you can increase the length to make it more like whatever stuff. But if you're doing a static one, this is the way. But we are going to animate it, so it becomes a problem. There are multiple ways to do the animation. One common way that I will do is that instead of defining or instead of making the animation afterwards, I will define a different pot. So using the same parameters, same curve, but I'm going to draw that differently. So I have a different pot. So it looks like this. So assume this is a completed stage, then now we have a two pot. And what we can do is to really just set the position, and we need to mix vector of it, and we need this position and this sampled position. And because the parameters are basically the same, we start with the same curve linear, we are using basically the same bevel curve, so we can use the index as a way to transfer information. So the position goes to position. So now we have this result. By manipulating this factor, we are going from the primary stage to the designed stage. Okay. There are pros and cons of this method. The pros is that you know how your product will look like eventually. The cons is that it looks kind of fake, the process. You can make the process looking more realistic for sure. But at the end of the day, it may still not looking very interactive with the object, the rods, which is used to shape this stuff. So you need to think about pros and cons in this case. Before we change our method, let's make a procedural rod, which we will use to shape our geometry. So let's name it rod. The reason I'm making it procedural is because I may change some parameter like the thickness of it. So let's name that as a rod. We basically do the same, erecting this spline, bevel curve, and I'm going to instance some points. I can instance UV sphere, or you can use ICO sphere. Make sure it's 32, 32. At least they should be the same, just to have a better looking. So now we're instancing 10 spheres. I'm going to restrict this instancing on endpoints, so starting and end. So now if I join this geometry, I have 2 spheres from starting to the end, and I'm going to use a single value precision node to synchronize the radius of my rod and this sphere. So outlooking, they looks like a rod if you make the resolution the same. Okay, but the internal geometry is a little bit problematic with this part, which I want to fix. So let's delete geometry. So I have this UV sphere, but I'm deleting it. I'm only going to delete half. So let's use a position, separate XYZ. If the z is greater than 0, then I'm going to delete that. So we only have this half sphere. And then if I join geometry, it looks like this. Make sure that you realize instance. This is very important. Otherwise, this sphere is not accessible for future use. Okay. The top part still looks kind of problematic, but you can tweak that in your free time. It's not really important in this particular case. And the benefit of this is that I can really increase the length of it, and I can increase the thickness of it. Okay. In case if I want to change anything. So then I can merge distance just to make that a single structure instead of 2 separate geometry. I don't know if this is necessary, but anyway. And we can use a set shade smooth just to make it look nicer in final render. And then instead of moving these rod objects, I'm going to parent that to empty. There is no real reason to do that. It just makes me feeling more comfortable in case if I were to change anything. So that now if I'm using empty to move it, it's working. Okay. I think it's a little bit more convenient than moving the rod due to certain reasons. But anyway, so now we can use this empty. Yes, I need to show this rod. To control this rod, and we are using this empty to shape the structure of it. So now we're going to change this method. Again, I want to clarify that this method is not really bad. It's just not really realistic because you are predefining a stage. But my advice, if you want to adhere this method, is that you may want to use the simulation zone, and you may want to use a proximity fold. And you can use the object mesh, and using this fold to control the factor, so everything is more local. And we can use scale offset. More local mixing from original stage and the predefined stage. Okay, and when you combine it with the simulation, it may look okay, but as you see, it already appears to have some problems because it will be clamped at this predefined stage. Okay, but anyway, that's really not the topic today, so I'm not going deeper. I'm just going to name that as a method A, and I'm going to duplicate to make method B, and I'm going to delete this whatever stuff, but only leave the simulation zone. And I'm going to introduce a new preset which is called collision deformer. Okay. The name is derived from Cinema 4D. It should be a very useful concept. There are many different uses of it, but the implementation may not be as good as the one in Cinema 4D. But I tried. Anyway, the idea sometimes can be make a fake cloth simulation. But I made several animations. It seems people aren't very interested in that. So whatever. I'm going to use this rod as a collider. And by manipulating this empty, you should be able to see some deformation. And it's not very obvious now because we don't have enough subdivision of this pottery. You can increase this count, you can increase the resolutions, or you can use just a subdivision surface or subdivided mesh. Does not really matter. Here I'm just going to bump that to 250 and 250. So you have seen a lot of wires. And then we have this nice collision which is going on. Of course, there's a threshold, so if you really push inside, it will not deform. Or it will not really deform because you can see this. But it looks kind of okay. It's not that bad. Yeah, it's working very well at some point. The really good part of it is that I implemented the fourth distance. It really took me a lot of brain cells to implement this, so that you can add some sort of noise during this collision, and you can control the frequency of the noise and the scale of the noise. It can be really useful because it looks kind of cloth deformation. Okay, but we're doing a kind of pottery, so not a cloth. So maybe we're not using that. Anyway, so let's just use a default collision deformer so that we are cleaning every parameters to its default value. So this is how it looks like. And I'm not going to join collider geometry because I don't want to see that in simulation zone. Okay. Next, what we're going to do is just to put this collision deformer into simulation zone so that we're deforming that every frame. And I'm going to use a transform geometry to just rotate that. We can rotate by 5 degrees per frame. Then you can see we'll start moving it, and let's increase the time count. Okay, so now if I play this animation, it's rotating, and every frame is being deformed as well, and it's generated this whatever. But you also realize there are some bugs. Okay, it's very difficult to explain why this bug occurs. It's basically because that's you are folding the surface, which misled the collision detection. Okay, I think the way to solve it is just to be gentle to this pottery. So just give a light touch, then you will never have a problem. But if you just poke inside, then immediately you will have this kind of bug. Okay, so be gentle with your product. So now we play this animation, we just gently touch that, and touch, and then you just play around. You also have to be very patient to make this pottery. Of course, in reality, I don't think it's very productive to doing this kind of keyframe or auto keyframe. I think you want to use a path to guide the movement of this empty or stick or rod. so that you have a more kind of control. It's just a kind of idea. And you can use this empty to follow path. And I'm going to fix the position. And yes. So start from 0, 400, factor 1. So now if I play this animation, it's not touching, but later it starts to touch. It generates kind of a spiral shape, and then it leaves. So we get something like that. Okay, so this is the kind of idea. Here it's possible that people do not want to render like 400 frames. They want to speed up this entire process. So you can change the keyframes to 200 frames. So 2 times. And then you play this animation, you can realize that because it's running too fast, it's not finishing a cycle. So what may happen is that people want to increase the step per frame. So I'm rotating 15 degrees. Then you will have these kind of gaps. Because we are rotating too fast, sometimes the collision is not being registered properly, and so on. So to do the subframe in 4.0, because we do not have this function implemented yet, you can use repeat zone instead. So we basically divide this 15 degrees into iterations times degree. So let's take a 3 times 5. And we basically use repeat zone to cover. Repeat zone is very similar to simulation zone. The only difference between two is the simulation zone is working over time, but the repeat zone is working over iterations. So we basically use 3 times 5 to generate this 15 degrees result. So now we're basically running everything the same, but you have less gaps. Okay. And you can also increase these iterations. So maybe 5 times 5. So that's whatever. Okay, this is just kind of idea. You can try to play around these settings to deal with different kinds of results you're having. Okay. So anyway, you can also use a smooth position to deal with this kind of undesired ridges, whatever. And I also want to mention about how to generate noise. But really, noise displacement is nothing really new. You take a set position, you take a noise 3D, and you increase the frequency. Because we're using a 3D noise, so they may intersect each other. This is some parts that you need to be cautious with. And with this kind of a folded surface, you likely will generate bugs within this collision deformer. So as an alternative, you can use normal displacement, which is more common. So that no matter how you increase the scale, they will never intersect. So it's up to you. And this is parametrical, so you can just duplicate the noise. You can increase more frequencies for one noise and decrease frequency for the other, so that you generate some more general patterns and plus that with more specific patterns. Up to you. There is no right or wrong answer. But I just want to warn you, whatever you do, it will turns out to be associated with the subdivision level of your pot. Okay, so you need the polygons to do the displacements in geometry nodes, and usually it will be very slow. As you see, that's my FPS is already 4. So what you can do is that you may just decrease the subdivision level, maybe make that to 100. So we're losing a lot of details, but it's also faster. So at the end of the day, deal with the parameters, change the settings, see your needs, and so on. Whatever I'm introducing is just an example. In reality, if you're making a serious animation, everything needs to be more complicated and you need to be more cautious with lots of things. But anyway, I hope you enjoyed this video. I'll probably see you next time. Bye bye.